So welcome back. We're going to continue solving the exponential and logarithmic equations. So we stopped the last time by this problem. E to the x minus 8 to e to the x minus 20 equals 0. So in order to solve that, the first thing you can do that, okay, is there any similarity between e to the 2x and e to the x? Can we twist this a little to make it similar to that one? So think about this one. Can we write this as e to x squared? Because 2 times x is 2x. So it's the same idea. Minus 8 e to the x minus 20 equals 0. Think about this problem. Here's something squared, minus 8, something first degree, and minus 20. Does it look familiar to you? Yes, it's a quadratic equation. If this x, and here it is x squared, here 8x minus 20, that would be perfect. So what if I set y equals e to the x? And I'm going to rewrite this equation. So I'm going to substitute e to the x by y. I have y squared minus 8y minus 20 equals 0. Straightforward quadratic equation. Factor and solve for x, or solve for y here. Okay, y, 20. I need a product of two numbers that equal negative 20, and their difference is negative 8. So basically that negative 10 and plus 2. Okay, use zero product rule. So I get here y is 10, and I got here y is negative 2. Okay, that's nothing new. We know how to do that. The next step is the most important step, is to substitute back, or do back substitution to e to the x. So that means here e to the x equals 10. So how can I solve for x here? I'm not solving for e to the x, I'm solving for x. So take the natural log, because the base is e. So I'm going to take the natural log, e to the x on both sides, equals natural log of 10. And here, based on the rule that I had before, the log b to the x equals x. So the natural log e to the x equals x. So x is the natural log of 10. Okay? Okay. Basically, if you don't have to look at this way, but if you use a power rule, this is equal x natural log of e. And natural log of e is always 1. So x times 1 is x. Alright, I hope that this example is clear. So let's get another example. Maybe another color. Alright, so I told you before that if log b to the x equals log b to y, that implies, and if and only if, two ways, that x equal y. I'm going to use this in some examples here. So example 1, log 2, by the way, that works with natural log as well. Log 2, base 2, of 5x minus 3 equals log base 2 of 3x plus 11. Log and log, same base, and equal. So therefore, x is y, So I have 3x minus, or 5x minus 3 equal 3x plus 11. Straightforward linear equation, and I can solve that. So minus 3x, I'm going to put x on one side and the constants on the other side. So I have here 3 plus 5 is 8x equal 14. Is it 8? I'm sorry, it's, okay, subtract 3x, so I have 2x. So therefore divide by 2, so x is 7. Okay? Look at the rule and take the arguments of both sides, set them to equal to each other based on the rule, and solve for x. Alright, I'm going to go with 3 more examples. So we have log 3 to the x equals 2 plus log 3 to x minus 1. Okay, here I don't have this rule, so it looks different here. So the first thing you think about it is to put the log on one side because of this 2. So I will subtract negative log 3 to x minus 1 from both sides. Negative log base 3 to x minus 1. So this is cancelled out. So I have here log 3 to the x minus log 3 to x minus 1 equal 2. All right. Does that look familiar to you? Difference between two logs. Can we combine them in one log? Yes. Why do I need that? Because with this, I can convert this to exponential rule and evaluate it in terms of 2. But without that, I can't fix this problem. So let's see. I have the same base, okay, and minus. So I'm going to convert it to division. The positive log would be on the numerator and the negative log would be in the denominator. So I have here, I will combine these two logs in one log with base 3, and I have x over x minus 1, and this is equal to. So one log equals number. Can I use, this is a logarithm form. Can I convert it to the exponential form? Base times the exponent equals the argument. So now I have 3 squared is equal to x over x minus 1. Okay, so what is 3 squared? I have 9, so 9 is x over x minus 1. Okay, cross multiplication or multiply both sides by x minus 1. So I would get here 9 times x minus 1 equals x. Okay, distribute, so I have 9x minus 9 equals x. Subtract x, or move x to the other side, and a negative 9, add 9 to both sides. So I have 8x equal 9. And then divide by 8, and I will get x equals 9 over 8. Now, the best way is to check. Make sure you don't have a negative log here. Because this is 9 over 8, so minus 1 is 8 over 8, so you're going to get a positive number. But if this less than 8 over 8, suppose that you have 7 over 8, you're going to have a problem here because you're going to have negative 1/8, so that doesn't work. So you have to check it to make sure that it works. However, it works here. Okay? Alright, let's get one more example. Actually, I didn't count the examples, so whatever I have. So one more example does not mean that's the last one. Okay, so let's get this one. The natural log of 4x minus 1 equals 5. So there is 2 ways to think about this problem. way number one is to use b to log b to the x equal x. So this is a way to think about it. And here's the base is e. So you think about e. Okay, the other way is to convert this one to the exponential form. Okay, as we did here. I'm going to use the exponential form first, and I'll show you how to do it in the two ways. So what's the base here? E. So this, the e to the exponent 5, e to the fifth, is 4x minus 1. Correct? Okay. Then we solve for x. I add 1 to both sides. So I have e to the fifth plus 1 equals 4x divided by 4. So e to the fifth plus 1 divided by 4 equals x. Okay, convert it to exponential form and then isolate x. The other way is to raise both sides to e using this way. So this is, when I raise it to e, so e to the natural log of 4x minus 1 equal e to the fifth. Do you see what I did? I raised everything to exponential way with e. So what's going to happen here? E to the natural log of that number, okay, b to the log of that number equals that number. So x equals x here. So that means that this is 4x minus 1 is e to the fifth. Which what we stopped here and here, and now you can do the same thing and get the same answer. Whichever you'd like, both of them are correct. But sometimes I have to use this. Because sometimes you don't have an option. Like you can have something more difficult here, so you can't use this rule. However, now you're an expert. You know both of the rules, so you can choose whichever you'd like and what matches your problem. Let's get one example. And this example is application. So I'm going to read the question, or I can write it down. Bob invested $2,000 at 4% compounded monthly. How long? Ask about the time. Will it take the account to increase to $2,500 or $2,500. Okay, so let's state the formula first. So I have the amount equals the principal of 1 plus R over N times N or to NT, where R is the rate in decimal, P is the principal. So let's see, here's the principal, this is P, and here's the rate, R, but that must be 0.04. Monthly, this is N, and N is 12, because it's each month. How long will it take? How long means T, so T is unknown. Take the account to increase to 2500, and this is A. So now I analyzed the problem, and everything in the problem is clear. So let's try to put this here. What is A? $2,500. P, $2,000 times 1 plus R is 0.04 over N is 12 to 12 and T I don't know, I do not know T. Now I'm giving this problem. Can you solve for T? It is okay if I have T here, because this is how we learned before. But now T is an exponent. So now we have to use the logarithm. This is one of the important thing about using the logarithmic equation. So let's see what it goes. First of all, get rid of this 2000. So I have to divide by 2000. By 2000. Okay? So this is 1. Here, 2500 over 2000 is 1.25, which is equal 1 plus 0.04 over 12 of 12t. Now, of course you can combine this together, and I think that you're going to get 1 plus 0.01 divided by 0.01 divided by 3. So it's so there's going to be 3.01 divided by 3. So, however, I'm not worried about this one. So keep it as it is. Take the natural log of both sides. Natural log or base or log, it doesn't matter, because it doesn't matter with the base. I don't have base 10 or e. So I'm going to take the natural log. The natural log of both sides, natural log of 1.25 is a natural log of 1 plus 0.04, and again I'm not worrying about computing this, of 12t. Okay? Now, I'll continue here. I have the natural log of 1.25 equal 12t. I'm going to use the power rule. I'm going to get the 12t first here in the front of the natural log. 12t times the natural log of 1 plus 0.04 divided by 12. Now divide by everything but t. So I divide by 12, divide this by 12 times the natural log of 1 plus 0.04 over 12. The same thing here, 12, the natural log of 1 plus 0.04 over 12. And now everything would be cancelled out here but t. And if you compute that, I got the answer here is 5. Where is that? I got here 5.59, and that would be in years. So, years. Alright. I hope that this example is clear, and I see you in next section. Thank you, and have a good one.